Good evening, folks. Well, today I had the occasion to stumble on a recording that was made by Jose Gonzalez, which was a small part of a discussion apparently that he was having with some flat earther called Slick James. And this video is really designed to object to the things that I heard on that. From this Slick James person. So what he's basically saying is that we're all indoctrinated because at school they tell us stuff, but they don't present any evidence. We just expected to accept everything that everybody tells us and then regurgitate it back again without any evidence that the stuff they're telling us is either factual or comes with any evidence, underpinned by any evidence at all. This is what he's saying. I'll tell you why he says this nonsense. Okay, just like most of the flat earthers, he has squandered his opportunity for education. Now he feels like to gain some sort of importance, he establishes himself with a group that pretends to know something that the rest of us don't. And in order to keep this going, has to make up bullshit like the rest of us are indoctrinated, we've got it all wrong, thousands of years of science is wrong, and that they are all correct. This little band of imbeciles, if you like, okay, these misfits who, when given the opportunity for an education, squandered it. And you'd think that later in life they would have woken up to the fact that, hang on a second, I didn't get a chance to get an education then, or I didn't give myself a chance to get an education then, so why don't I try to get one now? Instead of going around talking and making up bullshit. Alright, let me show you why you're wrong about what happens in education. We're not indoctrinated. Every time we're told something or we're given some information, it's backed up by evidence. This evidence can be a demonstration of an experiment, or it can talk about research that's already happened. In any case, our knowledge is built on previous knowledge that came before us. In your simple mind, if you only accepted things that you did firsthand, science would never progress. So let's have a look at this board and see what examples I can give you. Chemistry. So I'm just talking about the stuff that I'm very familiar with, okay? Because obviously this extends to other things like geology, biology, paleontology, numerous other fields of science for which I don't bother myself with. I have got no time for all of that. But this is what I do know. Atomic structure. We teach students about atomic structure. We teach them what the models are for atomic structure. For instance, like the Bohr model, okay, Rutherford's model. We teach these models because it allows us to explain how things happen and how we can make predictions from the way those things happen. Okay, so how do we know that the model works? It's because we have things like spectroscopy. The predictability of products in reactions. Mass spectrometers work because the atomic structure model works. We can make accurate predictions. And these predictions are borne out in reality. This is done in university labs. They have things like mass spectrometers. They cost millions of dollars, these things. They don't have them there for show. They actually work. They actually provide evidence for what's taught. Electrons and ions. How do we know that model works? How do we know that these are a fact? Galvanic cells, redox reactions, electricity. This is how we know they work. This isn't something they just tell you. Chemical reactions. They're not just numbers and letters on a page. They mean something. Together with the atomic structure and the way that chemicals react together, these are entirely predictable things. You're not just taught them, you're also shown the evidence. Acid-base reactions. If you hadn't squandered your education in high school, you would have at least done some titrations. And if you had any ounce of intelligence, you'd understand what those titrations mean and what they're for. Clearly you don't. Thermodynamics. I hear that word bandied around a lot, especially the second law of thermodynamics. I would seriously doubt that any one of you actually understands what it means or have done any serious reading on how it works. Who put this together? Read the actual scientific paper that goes along with it. Looks at the difference between gas pressures on Earth and the atmospheric pressure. What do these two things mean and how are they different? Measure of predicted exothermic and endothermic reactions is a demonstration of this. If you hadn't squandered your education, you would know this. Equilibrium reactions. Combustion reactions. We can make predictions about this. We don't just go like this and wonder how many kilograms of hydrogen and how many kilograms of oxidizer do we put on a rocket. We don't guess. There is no book of Flirt experience that tells us what to do or how much to do it. We don't guess these things. We make predictions based on the knowledge of how they work, of how chemical reactions work, of how combustion reactions work. When we teach these things, we demonstrate them. We demonstrate how combustion reactions work. When we teach rocket science, or we teach satellite physics, we take students out there and we show them. We show them the evidence. Let's look at physics. Gravitational acceleration. We don't need to just tell people that there's gravitational acceleration. We can demonstrate it, and we do. We show them how something falls and how long it takes for it to fall. We can show them that it's accelerating. We can prove that it's accelerating. What about that bullshit about it being density, relative density? How does this relative density explain acceleration? How does it explain something if I throw something up? How do I know exactly how high it's going to go? How do I know how long it's going to take before it reaches the top of where it's going to go and then comes down again? How do I know this? I don't have to tell students this. I can ask them to do it themselves and measure it themselves, and they do. The gas laws. It's not by accident that they know this. It's not by accident that we know this. When I explain the gas laws, I demonstrate it. I show them how atmospheric pressure is different to pressure in a container, gas pressure in a container, how these things are different. I show them how you can calculate the amount of gas in a particular volume. I show them how you can create gases and how you know how much you'll get. This isn't something we tell students and hope that they'll just remember it. We show them. We demonstrate this. We spend millions of dollars in laboratories all over the world. Billions of dollars. What do you think these laboratories are for? Newton's laws of universal gravitation. Gravitational fields. These aren't just things that we just say. These are demonstrated things. Experiments, like Cavendish experiment. That's repeated. It's a classic experiment that demonstrates that objects will appear to be attracted to each other. That's what they look like when you see that. They attracted to each other. We now know from Einstein's model, from Einstein's work, that what it is actually things coming together because they fall together in the well of space-time. So we know what that means. That does not discount the work that Cavendish did. So why are you bullshitting to everybody and yourself? Projectile motion, circular motion. All of these things are demonstrated. That's how students learn. They learn because we give them some facts and then we underpin those facts by real world, real life demonstrations. That's what we have lab sessions for. Force, momentum, work, energy. All of these things are explained with demonstrations, experiments. We demand of students that they do experiments. It's not even a suggestion. We assess them on their ability to understand a concept and to demonstrate that concept. The photoelectric effect, the speed of light, refraction, diffraction. All of these are demonstrated in laboratories. These are not just things we tell students. In real world observations, when these things are made, students understand what's happening. In fact, everybody understands what's happening. Whoever bothered not to squander their education. Nuclear fission. Nuclear fusion that's happening in our sun. We know what's happening in the sun. That's because we have this stuff. We can analyze accurately what those elements are. We can have a look at the radiation that's been given off. And we know this is exactly what happens in a fusion reaction. It's not an accident. It's not magic. And when we tell students this, we demonstrate it. We show them how this spectroscopy works. We show them how we can pick an unknown sample and use that to determine what it is. We might give a student an unknown sample. We know what the sample is. This happens almost all the time. I know what the sample is. I purposely give the student something difficult to analyze. And I know that the student knows how to do this work because they produce the results that match what I know it to be. So if I give somebody a sample of argon and I ask them to analyze it, and they come back with the results for argon, I'm pretty confident they know what they're doing. Not only do they understand the concept, but they understand how to actually do it. This is what happens in schools. Not the bullshit you say. Satellite motion. You think those things are up there by accident? You don't think that it takes a lot of work to get those things up there, those satellites up there? They cost hundreds of millions of dollars. You don't think that when we tell students how these things work, we don't take a lot of trouble to demonstrate it? You think we let students loose on a $100 million satellite? If you're even capable of this, think. Particle accelerators. Hundreds of millions of dollars for one of these. Do you think they're there for nothing? You think when we have quantum physics and we teach that, and we take people to the particle accelerator to demonstrate these things, you think we're just telling them stuff? Okay. Get this into your thick heads. Science doesn't work like indoctrination. Indoctrination is what you have. You listen to your Nathan Oakleys and Globebusters and other idiots who are actually taking money from you under false pretenses. You listen to them. And then you ignore the real science that's happening around you. There was once a time when you were offered education and you squandered it. And now, thanks to the technology, you're able to redeem yourself. But what do? You squander it yet again. Okay. Change. It's not too late. As long as you're alive, you can learn. Okay? Get out of this stupid cult. There's a whole world of science out there that's really, really exciting. You can learn at the cutting edge of science. You can participate in the science. You can participate in the knowledge that's happening. You can join groups that are looking for new planets and new stars. You can be part of this exciting world. Okay, I think that's enough. Alright, if you enjoy my videos, please press the like button. If you're a flurfer, there's no doubt you will not have liked this, so please smash that dislike button. Okay? Alright, if you haven't subscribed, go ahead. Press that bell as well so that you'll know when I'm doing these again. I'll see you later.